Let's look now at configuring advanced DNS services with DNSSEC. Okay, so DNS is one of the most widely used services on a Windows network or any network, and therefore it's prone to attack. Malicious users can access DNS if it's not configured correctly to take over a system, or through denial of service attacks, prevent other legitimate users from accessing the system. So on the slide here, we see the machine on the left does have DNSSEC extensions configured, and the attacker down in the middle is prevented from accessing those DNS server records. Whereas on the right, the DNSSEC is not configured on the server, and in this example, the attacker is able to successfully hack in and either intercept communication or modify existing DNS records on the DNS server. So what is the architecture of DNSSEC? We have what are called digital signatures to secure resource records stored in the DNS server. This is created when the DNS zone is marked as DNSSEC secured, and we have what are called resource record signature files, also abbreviated as RRSIG records. So then each existing record or new records created would get a new RRSIG record. Okay, so let's go to the next slide here. So we have when a DNSSEC aware client queries for a DNS record, the name server returns the RRSIG record. And that can be validated against a public key called a DNS key. That's also stored in the same DNS zone on the same server. We'll go over DNS zones again later on in this lesson. So then the public key can be used on the client system to check whether the RRSIG record has been tampered with or not. If the key has been tampered with, then the client can stop the transaction. Other features of DNS architecture, we have trust points and the name resolution policy table, or NRPT. So trust points are a way to share the public key used to validate the RRSIG's, that record's digital signature. If you've got DNS set up in Active Directory, which in most cases you would, then that takes care automatically of having trust points on every AD DNS server. If you don't, you can manually add trust points by importing the DNS key from a secured zone DNS server. The name resolution policy table has a table that lists zones or namespaces that perform a DNSSEC-based query, and also references those that do not. So clients that are aware of DNSSEC use this table to perform either validated or normal DNS queries. You can distribute the name resolution policy table using group policy or by modifying registry entries on client systems. So group policy would be the easiest and most efficient, accurate way to distribute the name resolution policy table. The NSEC records. So when you have a DNSSEC secured server, the server needs to respond with a valid response. However, this may not be possible if the requested system name does not yet exist in the records. In that case, DNS Secure uses a special record type called Next Secure Record, NSEC, and that sends responses using hash keys instead of clear text. Why is this a benefit? Because if you do have an attacking system that's intercepting traffic, that system will not be able to decode the DNS traffic as it would be able to if the communication was sent in clear text.